Going on to the last module that we have in our Math 105M course, Section 6, Solving Exponential and Logarithmic Equations. Now again, there's some background that I'd like to give you, and we'll use the PowerPoint slides that we used before. There's the title page. And what we'll be doing here, and this is something we did a little earlier, actually it was here in section 6.3 where we did some like this. These were solving exponential equations. Now an exponential equation has a variable as the exponents. And you may recall we said as long as your bases were the same, then your exponents equaled each other. Here's an example that will actually work out for you. We did one very similar to this in an earlier lesson. But there's our exponential equation. We want to find out what x is. So 5 to the x power. Now we're looking at 125 to see if we can put that with a base of 5. And we can, because if we cube 5 to the third power is 125. So now that our bases are equal, then x equals 3. And this is the method we use to solve. Now, when we are working with logarithmic equality, that is, equations that involve logs, the log value must always be greater than 0. You can't have a value for a negative log. It's not defined. So our value has to be greater than 0. We'll see this coming up in some equations. Now, in this example, it is an equation that is of the exponential type, where the x is in the exponent's position. Now here, if this were a 9, we could put it 3 to the second, and then our exponent here would equal the 2 there. But there is no power of 3 that would ever become. Now, we need to convert this into its logarithmic form. So we're going to put log base 10, that I'm not going to write, of 3. Now what do I do with this exponent? I put this exponent in front as x plus 1. And then I convert the other side to log base 10, that I'm not writing, of 43. So a simple little change here. I've converted an exponential equation into a logarithmic equation, and again putting our exponent in front of the log. That's a technique we had earlier. Now, how do I get the x plus 1 by itself? Well, here I'm going to divide both sides by the log of 3. Now these cancel out, and on this side I'm left with x plus 1 equals the log of 43 divided by the log of 3. Now, how do I get the x by itself? Well, I subtract 1 from both sides, or just transpose this to the other side where it becomes a negative 1 over here, and I'll erase this to save a little room. But you have the notes. Now, how do I solve this? Well, I solve this by putting log 43 into my calculator, and then I have to close the parenthesis on mine, hit the division key, put log 3, close the parenthesis, hit enter, and then I subtract 1 from this answer, and I get x equals 2.4236. Now keep in mind this is an approximation. This would be the exact answer. This is the approximation. Now, on your exit exam that many of you may be getting ready for, this is the work you would have to show if you had an equation like this. And on last year's, they did have one like this. So you had to know how to convert it and then put it in this form. This is the work we would need to see to give you credit for this answer. The work is super important, and you gain mastery of this by physically doing it and then practicing it with your practice in QuizMes, and then of course on your Module 6 post-test. Now for this example, and we have some like this on our mini lecture booklet, here this is a natural log that we're going to convert this exponential to, so it'll look like this. Natural log, base e, and then e here, and we're going to take this and put that in front, and this will become 1.32t equals the natural log base e of 2000. Now this is critical, and we had mentioned before, what is this relationship going to become here when our base is e and it's of e? Well, e over e is actually 1. So all of this part is going to become a 1. So I will erase this part here because it becomes a 1. So now when we get to do it, it's a little bit easier. So what we do is put, and we don't need this e here either, we're going to say, how do we solve for t here? Well, we're going to divide both sides by 1.32, and we're going to divide this side by 1.32. Now, when you put this into your calculator, you'll just put natural log, hit that key, 2000. You may have to put a parenthesis if they give you one like so. Mine does. But now you're going to divide it not by a logarithmic power, but just 1.32. And when you do that, you get the number 5.7583. Now, if you have your calculator, you should be trying out some of these. Now again, on your exit exam, if you get an example like this, and I know you'll have these on your post-test, this is the work you need to show to be sure you get full credit. And I just tried it out in my calculator, and this was a number here that I had to round up over there. Okay, let's go on. Now in this next part, we're going to have some background material for solving logarithmic equations in which we convert them to equivalent exponential equations. So we've done some of that too in 6.3. So here's our first example. Let's take a look at it. So we definitely see that this is in logarithmic form, and we're going to convert it to exponential form. So what is our base here? Well, our base is 2. Now, before I put the equal sign, what is our exponent? Well, over here, our exponent is 4. And our answer is this. So we have converted from its logarithmic form to its exponential form. And what is 2 to the 4th power? Well, this is 16. And we get a rather simple equation now, if I get the right numbers. So, how do we get rid of the 5? Well, we subtract 5 from both sides, or transpose it. This becomes 11. How do we get the x by itself? Divide both sides by 6, the numerical coefficient of x, and our answer is 11.6. So not too bad. But again, this is the work you need to show. Now, in this example, here again, we need to convert it to a form that we can put it into its exponential form. So notice this is the expanded logarithmic form. This is log. This is base 10 here that we're not writing. And then since this is plus, we're going to show multiplication here. And this equals 1. So we had to do this intermediate step, put it in its more condensed form. Now, and again, base 10 wasn't showing. You had to remember this was the common log, base 10. So now in exponential form, this 10 is our base, our exponent is 1, and our answer is this. Now I'll just distribute and get x squared plus 9x. Now we have a quadratic equation here. I'm going to transpose the 10 to this side, where it becomes a negative 10. And then make this the 0, having it now in standard form. Now I factor this. Generally that's how you'll do them here. And they're not hard to factor. And our 10 needs to be plus. This is a negative. So we get x equals 1. Or x equals a negative 10. Now keep in mind, if we put a negative 10 up here, that will make this negative. And we don't have values for negative logs. So this, even though it's generated through your working, this is rejected. And the only answer is this. Again, on your exit exam in Chapter 6 test, this is the only answer. Now, they may give you this. If you put both of these in there, they're going to count it wrong. Why? Because you can't have a log that is a negative. So this would be negative 10 plus 9. This would end up being a negative 1. And this one would be a negative 10. And you can't have that. So this negative 10 is not an answer. Now, in the PowerPoint slides, they do give a proof to say that your 1 is a true answer, while the negative 10, just what we've proven here a moment ago, is not a true answer. It's false. Now, in this one, as we look at it, and I've written it out here so you can see it a little better, this is the expanded log form. We want to put it in its condensed log form and then convert it to an exponential equation. So this is subtraction here. So this will become log of base 3. And this is going to be in the numerator 2x plus 3, while this will be in the denominator x minus 1, and this is going to equal 2. So converting this now, it will be base 3, this base 3, to the second power equals this fraction. 2x plus 3 over x minus 1. Now, 3 to the second power is 9. So I'm going to save a little room just by converting this to 9. And in a sense, it's 9 over 1. Now, what method can we use to solve this? And I'm indicating it. We're going to cross multiply. So this becomes 9x minus 9 as we multiply 9 and negative 1. And then this just becomes 2x plus 3. We're going to subtract 2x from both sides. This gives us 7x. We're going to add 9 to both sides. That gives us a 12. And we get x equals 12/7. And again, what have you done here? You've shown the work step by step to convert this from an expanded logarithmic form to a condensed log to an exponential equation, and you solve for x. Now, that was some extensive background, but you'll see as we go over our workbook here, very, very useful because we've covered most of the examples we're going to do. So here we have 3 to the 5x power. Now for this one, 27 does have a base of 3 to the third power. So now our bases are the same, our exponents equal each other, and we get then that x equals 3/5. Now if you get an easy one like this, again, this is the work you need to show of how you got the answer. I could recall when I check final exams, I look carefully to see that you're showing the work. Now, I give it 1 point for the correct answer. Some other instructors don't give any points for the correct answer. I give, if it's, I think it's like 25 questions, each question would be worth 4 points. I would give 1 point for the correct answer, and I give 3 points for the explanation or the work of how to arrive at the correct answer. So that's super important. Now, we did one like this just a little while ago, where we changed this to its log form. So let's do that. Log of base 10, we don't write that, 9, and then we put our exponent in front. And that would be in parentheses x plus 1. So we have to keep that as a unit. And now that equals log of 43. And that's base 10. We just don't write it. Now, to isolate the x part, we're going to divide both sides by the log of 9. So this then cancels out, and we're left with x plus 1 equals the log of 43 divided by the log of 9. And once again, how do you get rid of the positive 1 on this side? Transpose it to the other side, where it'll become a negative 1. And I can just erase it here. Now, this is the exact answer, and MATLAB will want an approximation. So when you put that in there, it becomes 0.712. Now, if you just did this part, it would be 1.712, but then when you subtracted the 1 from it, you get this. All right, now this one, again, we're going to convert it to its natural log. So natural log, and I'm going to put the base e there, of e. Now we take this part and put it in front. This is going to be 0.11 t, and there's enough of a difference here to make that clear. And this will be natural log of 775. Now, we had said when we have the natural log base e of e, this part just becomes a 1. And we have then on this side 0.11 t equals natural log of 775. So again, how do we solve this? Well, this 1 we can just eliminate here. To solve for t, we're going to divide both sides by 0.11. And keep in mind, this is not a log, it's just the number. And we then get t. This is the exact answer. But t approximately is 60.481. And I just checked this out with my calculator. This was a 0.5, so rounding it off to 3 decimal places, I made this a 1. Now again, I'm not showing a lot of work here, but this work is needed to give you full credit. And we're getting a few calls today. All right, letter D, since there's a variable in our little problem here, and that same variable is in the exponent, we don't have the technology to do that. If you put it in your calculator, you do get an answer, so we skip this problem. So let's go on to doing these. And now these are in logarithmic form. What we're asked to do is to convert them to exponential form to solve them. And our answers again approximated to 3 decimal places. So let's get started. I'll do this live with you. So our base is 5. Our exponent is 2. And this equals 7x minus 3. So this becomes 25 equal 7x minus 3. Transpose the negative 3 becomes 28 on this side. 7x, divide both sides by 7. X will equal 4. And again, this is what they'll have. Your conversion to exponential equation is this, and this is the solution. Now, for this one, it's a little more tricky. So a good technique there is put the letter E in there so you know that your base is the letter E. So natural log base E. So now when we convert this, our base is E, our exponent is 7, and that equals 3x. So again, we want to solve for x. What does x equal? Well, we just divide both sides by 3, and we get x equals this. And I'll just save myself some room by saying that. Now, that's the exact answer. If you put that into your calculator, you get x equals 365.544. So again, the tricky part was, what was the base here? It's not showing up that well. In fact, this, but remember, this is base E. So this is the base to this exponent equals this, and you solve for x. And then when you put in your calculator, E should be a value in your calculator, caret 7, divide by 3, you get this. All right, now for letter C, again, this is the expanded form, so we're going to put it in its condensed form, log base x, and then now it's multiplication x times x plus 6 equals 1. So, and our log here is 7. I don't know why I put an x there. There we go. So our base is 7. Our exponent is 1. And it equals this answer, which is x squared plus 6x. I'm now going to take the 7, transpose it to this side as a negative 7, and this then becomes a 0. Now what do? I factor this, and they're not difficult to factor usually. This needs to be a plus, this is a minus, so I have x equals a positive 1, x equals a negative 7. So we had one on our PowerPoint slides like this. Now, can you have a negative value as a log? And if you put your negative 7 in there, this is a negative 1, this is a negative 7. So the answer is no. So this one we reject, and this is our answer. Now, here's a case where if this is one of the answers, and you put that, they're going to count it wrong. But I'm going to be able to go in there, and since you did all of the work in conversion from logarithmic to exponential, factored it, I'm going to give you partial credit. All right, so out of the 4 points, I probably would give you 3 points. You'd lose 1 point for not, knowing the answer completely. But again, this is where the work can help you. You may have a wrong answer, but your work will give you partial credit. Okay, we're almost finished with the lecture. Now for letter D, we'll convert it to its condensed form up here. So log base 3, and we have a subtraction, so that means this will be a division, x minus 4, x plus 5, and that's going to equal 2. So now we'll convert it to its exponential form. So our base is 3, our exponent is 2, and that will equal this fraction, x minus 4 over x plus 5. Now, 3 to the second is 9. So I'm going to put a 9 here. In fact, 9 over 1. And here I can cross multiply. So I get 9x plus 45 equals x minus 4. Now I'm going to subtract an x from both sides. So I get 8x. I'm going to subtract 45 from both sides and get a negative 49. And now I'm going to divide both sides by 8. And I get x equals a negative 49/8. I've said it once, I'll say it again. You must show the work of how you got to this answer. And this is what we've done. The expanded logarithmic form, condensed logarithmic form, then we put it in the exponential equation form, cross-multiplied, solve for x. Okay, our last one is similar, and I'll set that up for you. Okay, so as we do this, I've condensed it a little bit. Now, since there's a log 13 on this side and a log 13 on this side, I can get rid of those just by dividing them out. Log 13 log 13. So now I'm left with the equation, and by the way, do you recognize this? These are conjugates that give me x squared minus 16 equals 9. Quadratic equation, I'm going to put it in standard form. X squared minus 25 equals 0. Now I factor that, and I get x plus 5, x minus 5 Here x equals -5. Here x equals 5. Now again, we can't have a negative value as a logarithm, so the -5 is out. And our only answer is this, and this is the work we have. Now I do have a practice exam posted, and if we have time, we'll go over it, but it is available online. For those of you who are taking the exit exam at this time, this is an excellent example because I show you what has been generated as problems and then the work needed so that for each example you would get full credit. And that's the key. And I'm always surprised by the number of people that get perfect scores on their exit exam. And again, we'll be checking homework logs as well as your mini lecture logbooks to develop your 10% of your grade from that. All right, well, good luck and good studying.